Good morning. Today we are going to discuss Greibach normal form or GNF. In the previous class, we discussed one form of context-free grammar which is called Chomsky normal form. The general expression for Chomsky normal form is A derives BC or A derives A. A derives BC or A derives A. That is, this is Chomsky normal form or CNF. That means the right hand side of every production should be either two non-terminals side by side or a single terminal. And for Greibach normal form, every production is of the form A derives A alpha. This is the standard form of A derives A alpha. That means this is Greibach normal form, and as you know, this is a context-free number. That means left-hand side of the expression is a single non-terminal, and right-hand side of this should start with a terminal. That is, here A derives small a alpha means the right-hand side of every expression or every production should start with a single terminal. That means right hand side of every production should start with a single terminal. That is A derives A alpha. Now, for that means if you have a production, then you have to convert every production has to be converted to this form. That means first symbol on the right hand side should be a terminal. Okay. So for that, what I'm going to do is we have to study what is left recursion and what is left factoring. Left recursion means suppose that you have a production A derives A alpha, that means A alpha or beta. That means A derives A alpha means here this is the left hand side and this is the right hand side. On either side of that production, if the same variable is coming, that means here A derives A alpha means this is the same symbol as that of this. Okay. For example, I am going to have say B derives say BCD. Here left hand side of this production is B and the first symbol on the right hand side is also the same variable. Same variable. If you have a production like this, then we call it as left recursion. Left recursion. This is called left recursion. And suppose that here beta is another production. Beta is another production. Now suppose that you are going to generate this A derives A alpha. Then again you are going to have A derives A alpha. That means A alpha. Now again you are going to expand this A, which is A alpha. That means at a point, if it has to terminate, you have to use this production beta. That means suppose that here you are going to have, you are using A derives beta, then this will be terminated. That means here this is A derives A alpha. A is replaced with A alpha. It is A alpha alpha. Then next one, this A is replaced with A alpha alpha alpha, and that is replaced with another A, or A derives A alpha, and A is replaced with another A alpha, and that is replaced with another A alpha, and finally it will be terminated when A is replaced with B beta alpha alpha alpha. Okay, that means the yield of this is beta, the string generated is beta alpha alpha alpha. Okay. But the thing is that if you have such a production, if you want this to be in this form, you have to eliminate that left recursion. You have to eliminate that left recursion. Suppose that means here when you are generating an yield for this, A derives A alpha, etc. That means you keep on substituting this A with A alpha, and at the point where you are replacing this A with beta, then that is terminated. So anyway, we know that the first symbol or the first string on the right hand side is beta. Now, when I am replacing this with this, when I am going to have a new variable called a dash, and I am going to have a derives beta a dash, and a dash derives alpha a dash or epsilon. That means here we have two productions, a derives a alpha or beta, and I am going to replace that. Then that means I have eliminated the left recursion here, and I have added one more variable to the set of variables, which is a dash, and I am going to have a derives beta a dash and a dash derives alpha a dash or epsilon. Say whether this will generate this string. For example, this is a, and I am going to have beta a dash. Okay. Now a dash derives alpha a dash derives alpha a dash. Again a dash derives alpha a dash. Again alpha a dash, and a dash derives epsilon, which is epsilon. Okay, that means now the yield is beta alpha. That means beta alpha. This is the yield. That means the same yield as that of this one. That means if you have such a production, if a derives a alpha or beta, that can be replaced by this. That means a derives beta a dash and a dash derives alpha a dash or epsilon. That means you can replace this a derives a alpha or beta with a derives beta a dash and a dash derives alpha a dash or epsilon. Okay. Now an example I will show you. Suppose that I have a production, say A derives A or B. Okay. Now I am going to replace this with A derives B A dash and A dash derives A dash or epsilon. That means A derives A alpha. This is alpha and B is beta. So A derives A alpha or beta can be replaced with A derives beta a dash. A derives beta is B a dash, and A dash derives alpha is A dash or epsilon. So this is the equivalent of this. And now in general we can extend this. We have the general form of this is, suppose that we have a set of productions having A derives A alpha 1, A alpha 2, etc. up to A alpha n, and A derives beta 1 or beta 2 or etc. up to beta m. That means here we have n productions which is having left recursion, and the termination, this type of m productions, this is not n productions, this is m productions. Okay, now I am going to replace this with this. That means this is a general form of productions having left recursion. Now when I am replacing this with an equivalent set, this is A derives beta 1 A dash or beta 2 A dash or beta 3 A dash or etc. up to beta m a dash. Now I have introduced a new variable a dash. I introduced a new variable which is a dash. This is the new variable. One more variable is there. Now we how many variables are there? Here in this case we have only one variable a, and I'm going to have a new variable a dash, and now I'm going to have a derives beta 1 a dash, beta 2 a dash, beta 3 a dash up to beta m a dash. That's why it is so. A derives beta 1 or beta 2 etc. up to beta n. Now, what is A dash? A dash derives alpha 1 A dash or alpha 2 A dash or etc. up to how many numbers? Alpha n A dash or last one is epsilon. This is the equivalent of this. Here this is having left recursion, whereas this is not having any left recursion. So that is called left recursion, and elimination of left recursion is also very important. When you are converting a grammar to its equivalent Greibach normal form, we need to have or we have to eliminate left recursion. Okay. Now suppose that I am going to have an example. Suppose that you have S derives A or 1 and A derives SS or 0. This is a very important example. SS derives A or 1 and A derives SS or 0. See, I am going to have S derives A or 1, and now I am going to S derives A. You have to take this A, and S derives 1 is already there. Now you have two productions. This is S production and this is A production. S production is having A on the right hand side as well as 1 on the right hand side. This S derives 1 is in Greibach normal form. Why? The first symbol on the right hand side is a terminal. Okay. Now what about S derives A? When I am replacing this A with, you can have two options. Now A can be replaced with SS or A can be replaced with 0. Now there are two options. First case is A is replaced with SS. Now this will become SSA. Right A. You need not bother about that A. The left A you are going to replace that with SSA, and the right and another option is this A is replaced with 0. That means that will be 0A. Now the set of production is like this. S derives SSA or 0A or 1. Okay. Now what I have done is S derives AA or 1. S derives 1 is in Greibach normal form. What about S derives A? That is not in Greibach normal form. We are trying to convert that to Greibach normal form. That means first symbol on the right hand side should be a terminal. For that, I am going to replace this A with A productions. A productions are A derives SS and A derives 0. Initially, we are going to replace the leftmost A with SS, the right hand side of this A. That is, this A is replaced with SS, then that will become S derives SSA. Or when you are replacing this A with 0, why? We have a production A derives 0. Now I am going to substitute 0 for A. I get 0A or 1. Okay. See, here this is a production. S derives SSA is having what? This is having left recursion. That means this is just like this S stands for A and this for A, and this is alpha, or this is beta 1 and this is beta 2. Okay. I am going to eliminate the left recursion from this. If you have a production A derives A alpha, or beta 1 or beta 2. When I am replacing this with, now I am going to have a new variable say a dash. Now I am going to have a raised beta 1 a dash or beta 2 a dash or not or. We have two beta productions. Now a derives beta 1 a dash or beta 2 a dash. Now what is a dash productions? A dash derives alpha a dash or epsilon. Now we have to replace this a, beta 1, beta 2, a dash, etc. etc. Now what do you get? See, listen here. When you are converting this, s derives s as a. You are going to replace this. This is just like a derives a alpha or beta 1 or beta 2. Just like here, s derives s as a. This s is a here. Si is alpha. 0a is beta 1 and this is beta 2. When I am replacing this with a is s derives what? A alpha. What is a? S derives beta 1 a dash. Beta 1 is 0a. 0a dash or beta 2 is 1 a dash. These are the S productions, and now I am going to have, instead of a dash, I am going to have S dash here. S dash derives what? Alpha a dash or epsilon. What is alpha? Alpha is SA. SA. This is alpha. What is alpha a dash? A dash or epsilon. See, these are the new set of productions. You have S derives 0 a dash or 1 a dash and S dash. This is actually either you have to replace this a dash with, so I am going to replace this with, okay, this is S dash and I am going to have S dash here. S dash and S dash here. S derives 0 a S dash or 1 S dash and S dash derives S a dash or epsilon. Okay, now see the right hand side of this S productions. This S production, the right hand side is starting with a terminal. What about this? That is also starting with a terminal. But here see, this S is not a terminal. So what are the S productions? S productions are S derives 0 a S dash and 1 S dash. So you have to replace this S with 0 a S dash and 1 S dash. Then this will become S dash derives, when I am replacing this S with 0 a S dash, 0 a S dash, a dash, a dash, or when I am replacing this S with 1 S dash, what will become? 1 S dash a dash or epsilon. That is, now the S productions are, these are the S productions and these are the S dash productions. So we have only 2 plus 3, 5 productions, and in this set of productions we are not having any. That means all these are in which form? Which form? Greibach normal form. That means for this S productions, here for the first production, first symbol on the right hand side is 0, which is a terminal. Here first symbol on the right hand side is also a terminal, that is also in Greibach normal form. S dash production, first symbol on the right hand side is 0. Here also first symbol on the right hand side is 0, and epsilon is 0. Now we know how to remove or eliminate epsilon productions. You can apply that. That means wherever there are S dash, you have to replace that. Here S dash can be replaced, but okay, that you have to do yourself. Anyway, this is the way we are converting a grammar to its equivalent Greibach normal form. Here, this is our question. This is our question, and here now S productions are in which form? S productions are in Greibach normal form. Once S productions are in Greibach normal form, you can easily A derives S or S0. Now this S has to be replaced with the S productions here. S productions are these two, and that means the set is final set is that is the S productions are S derives 0 A S dash or 1 S dash. 0 A S dash or 1 S dash, and S dash derives 0 A S dash A dash or 1 S dash A dash 1 S dash A dash or epsilon. Okay. Now here now we have converted this S productions into this form, Greibach normal form, and now this is not in Greibach normal form. How do you convert this? Now A derives SS. Now this S can be replaced with 0 A S dash or 1 S dash. So when you are replacing that S, A productions are A derives, when I am replacing this S with 0 A S dash, 0 A S dash, yes, that means what remains here is S, or when I am replacing this S with 1 S dash, this is 1 S dash and followed by S. Okay, these are the S productions and or 0. Okay, now what is this? Now see, in this for every production, the right hand side is starting with a single terminal. So here one of the production is not in Greibach normal form, which is S dash rise epsilon. You know how to eliminate that. That means here wherever there are S dash, you have to replace that S dash with epsilon. Then here we get two more productions, 0 A or 1. Okay, 0 A or 1, and here you will have 0 A dash and 1 A dash. That you have to do yourself. This is the way we are converting a grammar to its equivalent Greibach normal form. With this, I am going to conclude this session on Greibach normal form, and this conversion to Greibach normal form and elimination of left recursion is very important as far as this topic is concerned. So you have to be very careful about that. You have to study that and do a number of problems related to this. Thank you.